Let's do some exploratory data analysis that's really hard to do in Excel and CodeApp, but is much easier in Python and especially R. Let's say we have a data set with one row from each state, and we have something like how much money they spend on public education per student in thousands of dollars, the student-teacher ratio, the average teacher salary in thousands of dollars, the percent of people taking the SAT, and then the average verbal SAT score in the state, the average math SAT score, and the average total SAT score. We could, if we wanted, plot expenditure per student versus student-teacher ratio. We could plot expenditure per student versus average teacher salary, expenditure per student versus percent of people taking the SAT, etc. Then plot student-teacher ratio versus average teacher salary, student-teacher ratio versus percent of people taking the SAT, etc. That's going to be a lot of plots. It would have to be a lot of clicking and labeling stuff in Excel, for example, or CodeApp. But R and Python have automated ways to do that. What we're hoping to make here is called a matrix of scatterplots, or a scatterplot matrix, because there's a logical way to arrange all these scatterplots into a row and column table kind of format that's kind of like a matrix. So I have two files that do this, one that's in Python and one that's in R. They link to each other. So this shows the basics of importing some libraries that we'll need in Python, and configuring how we want the plots to show up, saying where we want to load the data from here, and then there's some other data sets you could play with if you want. Then actually reading the data from the URL and doing a little bit of investigation, seeing the first 5 rows, that's what we were just looking at. Maybe making a few changes if needed based on the characteristics of the data set. And next we'll look at a basic scatter plot. So this is percent of pupils taking the SAT versus average total SAT. And we could think about what correlation we see there and what that might mean. But that's just one scatter plot, and we want a dozen or more of all these different variables against each other. We might hope that if we just plot the data frame, we get something useful. We don't get a matrix of scatter plots. This plot has basically row number of the data frame along the x-axis, and then all of the column values on the y-axis, regardless of their scale. So the biggest one sets the scale. Sometimes this kind of plot would be useful. In particular, it could tell you, are things systematically increasing as the row number goes up or systematically decreasing? That could tell you about time trends, but here it's not all that important. So here's how we can make the scatterplot matrix in Python. We can just call one function, and it will automatically do all this for us. Let's take a sec to think about what this means. I know it's hard to read the labels here. Let's pick one we can read. So average total SAT is on the y-axis on this last row, and then each of the other variables, including average total SAT, is on the x-axis on this on all the columns. So this plot has x being expenditure per student and y being average total SAT. This plot is pupil-teacher ratio on the x-axis and average total SAT on the y-axis, etc. So this is all combinations of scatter plots for all those data points, for all those columns, except when a variable would be graphed versus itself. That would be a perfect straight line, and there's no use plotting that. So it will actually do a histogram here. So we can see this is the histogram for average total SAT because we're reading on the x-axis here. This is the histogram for average math SAT, etc. We're seeing interesting bimodal behavior that we might not have guessed. So that's how you can do a matrix of scatter plots in Python. But sometimes the labels run into each other. So let's take a look at the same thing in R. And so now we're again designating what URL we want to load from, maybe what the separator column character is. Is it a comma? Is it a space? Is it a tab? And then here's where we actually read it in. Taking a look at the data set here just to make sure it makes sense. Fixing some column names, looking at a summary, like what's the mean and median and maximum of each column. And then we can do just a single scatter plot. It shows 2 ways to do it. in the second one, the x-axis and y-axis labels are a little nicer. And then there's a bunch of different ways to do the matrix of scatter plots here, each with their own advantages. It does a better job not overlapping the labels here, but the column names get cut off a little bit. And then here's another way. Maybe it's hard to see all these light blue dots on the YouTube video, but that's okay because this one's kind of hard to read anyway with everything crammed into the diagonal squares, and it doesn't show us the histograms. And then if we scroll even farther down, now here's a really nice one. The names are still cut off a little bit, but it's really interesting. It adds to the scatter plots a nonlinear trend line, and that gives us an idea of how nonlinearly these data sets are behaving. And then the elements of the scatter plot matrix that are across from each other, across the diagonal, it would just be the same graph again anyway, but with the x and y axis flipped. So it uses that space to report the correlation coefficient. It puts it larger when the correlation coefficient is a larger number, and it adds stars to show something about the statistical significance, that is the p-value. So if there's no star, the p is bigger than 0.05. If there's one star, the p is smaller than 0.05 but larger than 0.01, I think. And 3 stars would mean less than 0.001, for example. So in R, you have these various graphing options that Python doesn't have by default. Here's another, it doesn't have the correlation coefficients or the nonlinear trend lines, but it still looks reasonably nice. So that's matrix of scatter plots, which is a really useful exploratory data analysis tool when you've got a big multivariate data set.